Hey class, Mr. Moydeen here. Hope about your sunglasses and your bathing suits because it's time to work on our tan lines. I'll just let that sink in while the groans continue. Okay, so the main thing to remember is the equation of a line in point slope form is here in the corner in red. The question here is what is the tangent line to this parabola at this point? So in a way I've saved you some work because I already gave you the y value. Here is 5. So in a sense, much of our work is already done. The x and the y value go in the x1 and y1 positions respectively. So all we really have to do is to find the slope. Well, the slope of a tangent line is the derivative. So here our derivative is fairly bloodless. So if y is equal to x squared plus x minus 1, then dy dx, and I'm using the notation here mainly to emphasize that its slope is 2x plus 1, and that would be 0 on the end there. So this is a function, derivative as a function, that takes inputs, and its output would be not the position, the y value, but the slope, the rate of change. So the value that I'm interested in, I can plug in any value I want, but the value I'm interested in is x equals negative 3, because that's this point right here. That's the x-coordinate. So I take 2 and I plug negative 3 in, and I add 1. That would be negative 6 plus 1, better known as negative 5. So bingo, I've found my slope. This right here is the slope function. At a specific point, it's negative 5. So I go back to my equation of a line here in the corner. So y minus the y value equals my slope, which I just found thanks to calculus, x plus 3. It's a little bit hard to graph in this form, so let me go ahead and solve for y. So that would be negative 5x minus 15. And add 5 to both sides, y equals negative 5x. Adding 5 would be negative minus 10. So there's my equation. So I'm going to do my best to graph this. My y-intercept is negative 10. I don't know if there's enough room for that here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Could have guessed. That's there at the bottom. So there's my point. I didn't use software to make this parabola, so it may not be quite perfect, but, well, let's see. Connect those. And what do you know? If you zoom in here, I don't think my zooming here will show up in the video, but my line is tangent. So point, slope, slope is derivative, find the derivative, plug in the x value, take that slope, put it into the function, whoops, and you'll have your answer.